So let's talk about infrastructure as code a little bit and how to make sure that our infrastructure is secure, right? I had a lot of discussions with my colleague who is one of the most important people in this company related to security, and he said to me a couple of things, and we had a very interesting discussion. This is my version. Security slows us down. I am DevOps, not a security guy. So I don't like it. No developers. No one likes it. But my colleague said that I hate DevOps because we don't think about security. And you know what? It's right. When we talk about DevOps, when we take everything what Agile gave us, right? What Agile is love, right? The speed, continuous deployments, continuous integration, continuous improvement. Right? Where is in this chain where we can put the old way of doing security? Right? So if we have pen test once per year, because this is expensive, right? It means that the deployment which we do next day, the pen test is obsolete at this moment, right? And what about the companies like AWS where the deployments are going like every 7 seconds? Of course, not for one service, but right? So it's quite impossible to connect these two worlds. It is? No, it's not. So my name is Piwosz. I am City Foundation Ambassador, DevOps Institute Ambassador, and AWS Community Builder. So I have a lot of free time in my life, and I work for EPAM system for 3.5 years right now as a system engineer. I'm leading DevOps Academy, where I teach people how to become DevOps. Well, the DevOps as I understand DevOps, and I am with a little bit, so they are with as well. And also I'm part of something that is called NGEX. This is an engineering excellence team. We do assessments of other companies about their engineering. So how good are they? So what is infrastructure as code? Who can tell me?
Come on, don't be shy. No, in general, in high level, what is infrastructure as code? I know you in the last in the last row. Mm-hmm. Mm-hmm. And you are wrong, because infrastructure as code is a fast, dynamic, programmable way to deploy hidden misconfiguration of the infrastructure everywhere. Right? And yeah, that's true. Because, spoiler, when I prepared to this talk, and not only this talk, but this topic, I did a scan of many available Terraforms, CloudFormations, etc., in GitHub. Who can tell me how many of them, what is the percentage where I didn't find anything? 0. Exactly, right? So, well, that's the point. And what we deal with. So we had the example of Twitter, right? So this is, come on, Twitter was enough, right? But in 2020, you probably heard about SolarWinds, right? And then it came again. Right? Everything what is nasty come with pairs. So few companies more, right? So all of them really were hacked, were breached, whatever else, right? News from last month. I will not add yours. This airports, etc., etc. It is quite again, let's say funny, right? But yeah, after Uber was hacked, did you see what happened on LinkedIn? They had like 30 positions open for the security immediately. The whole list. Right? So, well, So let's take a look at some numbers, and this will be maybe boring, but maybe it will give you some impulse in your head. So what is the average cost of the bridge in 2021, I think, from the IBM and Ponemon Institute reports? $4 and $35 million. This is average, right? From the things they were able to capture. So generally big companies, enterprises, etc., right? Average time to identify and contain the issue, 277 days. And this break is on purpose, 277 days. And 207 days is to identify, so to realize, oh, we were hacked, and then 70 days to fix it. Okay? Industry with the highest cost, obviously the picture is here, healthcare, 10 millions per breach. What a number, I want this on my account. Average cost per record, which was stolen, right? $164. For your name, for your name, for your name, for your data, credit card, I don't know, insurance number, etc., etc. Right? And now the interesting things, we are going to cloud finally. Percent of the cloud-based breaches in the whole number of breaches in this report. How do you think? 45%. Right? So that is the number which can say us how secure our clouds are, and not the cloud like AWS, I don't know, Oracle Cloud, Alibaba, whatever else, but our infrastructure there and our application in the cloud, right? Percent of breaches caused by cloud misconfigurations, and here we talk about infrastructure basically, right? 15%. Oh, maybe not that big number, but still, if you take 100 companies, it means that 15 of them was already breached because of this. It doesn't mean that they do not have this misconfiguration, but nobody found that probably, or they didn't say that. Right? Because there are two types of companies: those who were hacked and those who knows that were hacked. Right? And average cost caused by cloud misconfigurations, 4 millions. Again, I want this money. What kind of cloud misconfigurations we can identify? The most popular one, or ones? How do you think? Secrets are there, but the most popular are some different ones. So let's take an example. Imperva, 3 years ago, so old times, right? When dinosaurs was on Earth. They lost customer records like API keys, TLS, etc., right? Why? Because they had wrong configuration of network. They had hard-coded API keys. Who didn't do that? Let's throw the first stone, right? And not encrypted records in database. How long it takes for them? 10 months. Very secure, right? Next one, Capital One, the same year. They lost 100 million records, right? Or they exposed, the 100 million records was exposed, like bank accounts, social numbers, especially in US. This is quite important information, private information, right? Because IAM policies were wrongly configured, and they had unencrypted storages, right? So how many of you have encrypted storages in your accounts? Okay, so please remember, I can send this slide to you. So what kind of deployment exposures we have? Oh, sorry. 93% of findings there were misconfigured storage, right? So years ago, AWS by default had S3 storages available publicly. Of course, you had to do something more to really publish it, but that was general rule from AWS. It was publicly available. And believe me, there was like 1,000 crawlers around which went there and looked for this kind of open storages, right? 91% are about misconfigured security groups. Right? Of course, it is not 100% together, but if you have one, probably you have the second as well. 72% it's about hard-coded private keys. And 31% is about unused resources. You can ask what the problem with unused resources, right? It's the same problem like unpatched systems, right? There is something. This is unpatched probably. No one even remember that there is a server which is exposed to the internet with kernel 2 something and thousands of CVs there. And it's like playground for everyone around, right? So those are cloud misconfigurations. But also we have another element which is quite important. It is configuration drift. And here the fun begins, because when we can catch quite easily the misconfigurations in the initial script, initial approach, it's quite heavy, quite hard to find this in the drift, right? But we will be there. So the fact is that 90% of organization allows you to access production. We can say, okay, what's the problem with that, right? Well, how many of you went to your cloud account and just add something to security group just for 5 minutes, right? And then it was a phone, coffee, whatever, and SSH went open forever, right, to the world. Did it happen? Yes, I did that, right? Another fact, 33% of organization didn't start yet or is in early stage of implementation of security into infrastructure. So now the problem of Twitter becomes a little bit better visible why it happened, right? And this is really unbelievable, right? We talk about DevOps, DevSecOps, security, approaches, etc., and then we are going to the real life and you can forget about this. And now the things will go a little bit more interesting, because from the cloud security report done by last year, and they had 300 responders. Like 100 or more of 100 responders suffered a serious breach because of cloud misconfiguration. So the percentage is growing, like we can say from the previous report, right? And almost half of teams had more than 50 misconfiguration per day. Wow. Yeah, that's quite a number, 50 misconfigurations. So like a Swiss cheese is really solid comparing to that, right? And what kind of type of misconfigurations we have? Again, unused security groups, abandoned resources, not enabled logging. Yeah, Twitter is example, right? They do not know what's going on there. There is no encryption at rest. I don't want even to talk about encryption in transit, right? Security groups, IAMs, all kind of misconfiguration you can think of, you can dream of, right? And how they catch issues. And this is crazy in the world of DevOps, right? 33% do manual checks before deployment. So good luck with, for example, CloudFormation with 10,000 lines, right? And 27% catch this after the deployment. And it doesn't mean that this is deployment on test environment. It may be any kind of deployment, right? This is also crazy. How much people need to invest in order to catch issues in cloud configurations, right? So for the best number is on the end. 4% of the teams spend more than 500 hours per week. It means 12 people is involved in that. That's, well, it's 3 times bigger than my team now. And yeah, that's quite a number, I would say. I'm amazed all the time when I see this slide. So going back to drifts, what are the most popular drifts? Security groups. I told you about example, right? 100% of security of the drifts contains drift related to security group. And the best thing is that many tools we have right now, like for example, CloudFormation itself has this drift detection. It will not catch this. IAM policies. Of course, I will just add this asterisk there just to test something, right? And then I leave it. 82%. Compute resource creation, right? I will add 1 machine, 2 machine. Well, I will change the size of the machine manually because it's faster than go through the whole DevOps process, right? 48%. Not used and not removed the resources, 23%, right? And finally, CI/CD configurations is 21%. And this is something what DevOps world still doesn't understand, that CI/CD need its own security as well. Right? So is there anything we can do? Of course, everyone loves that. So process first. And I think, yeah. So first of all, we use infrastructure as code. So we have hands here, right? Then we check this. We also harden access for users. So no access to production. How much I don't like it, no access to production, right? There are other ways to do stuff. And no manual integration into infrastructure. Easier said than done, right? And the case what we need to change a little bit in the perception is related to the first slide, right? So we are very quick as DevOps, at least I want to think about this that way. And the security is quite slow, in my opinion, right? I mean, the security in the form of 10, 20 years ago, right? Which is still very popular. This is mine, right? The key thing is that if you find any kind of misconfiguration already deployed, doesn't matter on what environment, it's already too late, right? Like 5 years ago, 6 years ago, maybe a little bit more deeper into dark ages, it was like 30 minutes needed if you deployed Elasticsearch without security, and the time the Elasticsearch was really open, it was less than 30 minutes to be needed to be hacked, right? Checked on real example, right? And we can control our infrastructure before we deploy it because we have infrastructure as code. We can check it, right? For the application, we have SonarQube, etc., etc., etc. We have tools also for infrastructure as code. So we can use dedicated tools to prevent deployment of these misconfigurations, right? And we can do it into CI/CD because CI/CD can fail and would not allow you to continue. Right? This is the last resort for us. We can have pre-hooks, we can have pull requests, etc., etc. But this part CI/CD deployment is the last moment when we can stop something what is bad. And there is a lot of tools, right? So we have Checkoff, we have Terraform, we have DevSec, we have CFNNAG, which is only for CloudFormation. We have Snyk, right? They also have tools for it. And today we will compare 3 of those tools. All of them are free. First is Checkoff. It's visible somehow. Second, and Checkoff is offered by Bridgecrew. Then there is Terraform by Accurix. Right now, it's not Accurix, it's Tenable. And DevSec, which was bought last year, I think, by Aqua, right? And there is one difference between Chekhov and rest of them. Chekhov is written in Python, what means that when you install Chekhov, you install thousands of other things, right? And DevSec and Terraform is written in Golang. The big benefit of Chekhov is that Chekhov is not only able to scan your Terraform, your CloudFormation, but also everything what is related to Kubernetes. Also GitHub Actions, right? So you can use one tool to scan everything what you have related to, let's say, DevOps tools. Right? All are available as a container, which is quite nice, right? Because you can use them into pipeline, inside the pipeline very easily, right? And Terraform is interesting because it has API implemented. So you can have this up and running all the time and just send requests to it, right? You don't need to download anything, you don't need to run containers especially for that, etc., etc., etc. And how is this to implement it? How do you think? In the pipeline, how much work is needed for any of these tools? Yeah, I know you know already. But yes, this is true. This is everything what DevOps need to start using Chekhov to scan its own Terraform template. One line, right? Okay, 2 lines. Pip install Chekhov. Okay. And this is all, really all. And the same will be for Terraform, and the same will be for DevSec. But there will be 3 lines because you need to download the executable. Maybe you would like to put it into the proper path because I am sysadmin from my life, for my whole life, so I need to have this in proper place in my system and then to execute it, right? That's it. And what you can have after that, this is nice because this is example from AWS pipeline from Cloud Build, right? But for other Jenkins, Circle CI, Travis, etc., it will be quite similar, right? We can publish the report, right? And for Chekhov, it will look like this. You will have the full report, what was good, what was bad. You can, of course, fail the pipeline based on this. Why do not use it? How many times in the projects you saw that people are using it? Right, so my another question is a little bit, it doesn't have many sense because I wanted to ask how many times you see when people are using it, they are suppressing the fail action, right? Because you can do that with all of those tools. You can have this report just to have like a dry run, right? And the pipeline will continue. But this, okay, at least you are aware you have problems, right? That's something. All right, so let's see how it look really in a real example, in real pipeline. Hopefully I will be able to show you this. Where is here? All right. So I have our beautiful console of AWS, and I will go into code pipeline. And I have a pipeline which is failed, and this is the good sign. And in this pipeline, I have all 3 tools I already mentioned: Chekhov, DevSec, and Terraform, right? So let me just run this pipeline. So I'm collecting source. I just copied kind of random GitHub repository and do scan on it, right? I don't know, maybe I should send this report to author of this repository, but it's too risky. Right, and now code is collected and my three scanners are up and running, right? So let's take a look on, for example, checkoff first. So we have the logs. This is still in progress. All right, so we have a log. We can go through this log and see what's happening. In this pipeline, I'm doing this in the most intelligent way. So every single time I download, can I just make it a bigger a little bit? Yes. I download the package and install it, right? So it's not very effective, but well, we all do that, honestly speaking, right? So yeah, the problem with Python is that if I install one thing, I install 1,000 things. Still better than Node.js. When I install one thing, I install 10,000 things, right? So anyway, and right now, as you see, this checkoff is doing the test, right? And it ended with error, and I cannot find my mouse. All right, it's here. So as you can see, it took some time, but still we found errors. Let me jump into report. We have our report here, and we can see that 87 tests passed and 20 of them failed. And what kind of failures we have? For example, ensure that ALB redirects HTTP request into HTTPS one, right? So kind of basics, I would say. Ensure that load balancer is using TLS 1.2. Okay, right, it will be nice. I would prefer to have at least 1.3, but anyway, still something, right? This may be used as false positive because not all buckets must be replicated, right? Because sometimes the data stored in the bucket is not that important. So this may be treated as a false positive. Keys rotation is not enabled, right? Encryption for S3. Versioning on S3 also can be treated as a false positive, right? What I don't like about checkoff, that checkoff is, it's not here, but checkoff also as a fail will show you that you don't have a description for the rule in the security group. Is this a security risk, really? I'm not so sure. But anyway, so this is checkoff. Let's see what we have next. We've got TFSec, which failed just now. And similar thing, we have our log. Let's take a look. And the difference here is that what I had to do is to scroll up. Okay, where I am here, right? So I need to collect the executable from GitHub releases. So I'm doing it every single time, very smart. Yes, I am DevOps. Then I install this TFSec executable into USR local bin, just to be a proper sysadmin, to show you that I know my job, and execute the TFSec, right? So every single time, for every single of those three tools, I run this in that way that first I create the report, right, in JUnit format, and also I scan everything what is in directory. So for checkoff, it will be -d name of the directory. For TFSec, it will be dot, right? And then, of course, it failed here, right? Why it failed? Because we found a few things, hopefully. Yes, we have this report as well. And TFSec shows us only errors, right? And before we had around 20 something, if I remember correctly, let me check for checkoff. it was 20. For TFSec, we have 11. So this is the first difference, really important difference between those tools. They are focused on different things. They are showing different errors. I'm sorry, but this is the reality, right? And what we have, again, no versioning on the S3 bucket, no logging on S3 bucket. There is some wildcard in the policies. Very nice finding, right? This is what I said. I will just open everything for everything just for testing, right? On production, etc., etc. So KMS as well, elastic load balancers, etc. Right? Policy is found here for the first time. Chekhov didn't do that, unfortunately. I love Chekhov, but for Terraform itself, I suppose I will use TFSec or Terraform. Right, so this is a report from TFSec. And what we have next, our Terraform failed as well. Let's see, log. The action here is exactly the same like I've done for TFSec, so I need to download the executable, unpack it and put it into the directory. And then the command is very similar, terrascan scan, output is in JUnit, and please report, please create report for me. For terrascan, I don't need to put anything if I want to scan everything what is inside and under my directory, right? And again, it failed, and the report. How many findings it will be? More than TFSec, less than Chekhov, more than Chekhov, less than TFSec? Let's find out. 11 as well. And 19 is okay, right? And now we have also information about valuations, but this time in the report, it's not very informative, right? I mean, definitely less informative than, for example, for Chekhov. Of course, in every single one, we can go and see the solution or the problem. So Chekhov will show you in what kind of file it happened, in what line it happens, what is the solution proposed by Chekhov, right? And let's call it snippet of the code where the problem occurs. The same probably will be for TFSec. Yes. So we see that in main TF, in the between the lines 69 and 77, we have this, and the solution can be found here, right? And of course, we've got something similar for Terraform, right? Maybe less visually, a little bit worse, but anyway. What is the rule name? What is the severity? In which line, which file? What is the description? And we don't really have the helping hand where to find and how to fix it. This is the difference here. So that is how it looks, right? So as you already saw, it's 3 lines of code maximum. So if your DevOps will say you that, come on, it's too much, right? Just use your leg and send him to the moon, right? Believe me, it's quite powerful tool, and it's able to catch things which shouldn't be there, right? Especially if we talk about, well, security is important everywhere, right? But if you talk about healthcare, if you talk about insurance, if you talk about financial institutions, it becomes really, really, really critical, right? Okay, so this was the presentation, and I lost my mouse again. Yeah, I've got it. Right, so let's talk a little bit about drifts. What is the basic problem with drifts? That drifts need to be controlled continuously. Because if I do the drift detection right now, and I do the diff detection next time in a week, I have the whole week to log into my account and do whatever I want, right? And there is always someone who has elevated privileges. I mean it, always. Right? So the problem is that current tools don't cover everything. Right? I gave you the example. CloudFormation drift detection will not catch 100% probable problem with security groups, right? And the point is that we need to be strong enough to say to our managers, no, we can't do this on production directly because this is the security risk, right? Okay, you fired. And this is the problem. This is the really problem. What kind of tools we can use? So for example, yes, this drift detection will work, but not for everything, as I said. We have driftctl. We can use it. This will work also for Kubernetes, if I remember correctly. But kubediff will work for Kubernetes, right? We have really big tools from Bridgecrew, from Tenable right now, not Accurix. So those tools allows you to keep, let's say, the eye on your infrastructure and from one side, and on your repository with the code on the second side, and constantly check for the differences in both sides. And if something will be detected, it can even create a pull request and notify you that some change happened. Do something with that, right? Terraform itself doesn't have this possibility. Yes, we can use verify, maybe not verify, maybe plan, but it's not for this, right? So even for the infrastructure, let's not pretend that we have security, right? Because all misconfigurations will be exposed. It's the matter of time, really. And even in case of simple thing like security, like infrastructure as code, the security is very complex because fixing of those findings there, there's 20 findings, probably 18 findings will take like 5 minutes of work, but 2 of them maybe will take 2, 3, 4 weeks even because it's a really big change, right? So don't be frustrated with your infrastructure. Don't waste your time, like 500 hours. Just use scanners for your templates. Questions? Well, you saw that with all stuff which is not really needed, like collecting the package, install it, etc., etc. It took how long? Half a minute maybe. So yes, this is a issue many times, but the question is, let me answer by using the question. How many deployments per day you have? A day, right? So adding even 1 minute to each deployment will take 20 additional minutes, right? Is this really that big pain? Having from the second side the potential of having really secure or definitely much more secure infrastructure. Of course, when we blindly look on the execution time of the pipeline, because we love the DevOps measurements like DORA, right? Etc. 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 It will be longer. Yes, I agree. But first of all, we can do some things in parallel. We also can use the scanners in our local environment before we push things into repository even, right? So Still, I would prefer to have the scanner inside the pipeline, because I will see clearly what's going on, where I am, where I was, what is the trend, etc. But still, if this is a really big problem, use it locally. Right? Use it in pull request. Without this, you will not go into master. You will be not able to deploy. I hope this answers. Yeah, TF-scan, DevSec. Mm-hmm. Mm-hmm. There are tools like the one from Tenable, like the one from Bridge Crew, but they are quite expensive. And this is the issue still. This is quite new on the market. So probably there will be solutions soon, right? What we can do, well, for example, we can use the DriftCTL, and we have like a, I don't know, scheduled Lambda function in AWS and run it constantly, like every single hour, right? And check if things are changing, right? Or even having proper logging, proper audit approach, and do or execute some actions on it. AWS allows us to do it. I'm talking about AWS because I know AWS. But specifically for Terraform to catch it like a quickly, no, there is nothing, right? But it's not only for Terraform, for everything really. Mm-hmm. Mm-hmm. Maybe, yeah. Yeah, the point is, yes, the point here is that we have, like with deployments, right? We have deployment and we have continuous deployment. That's the big difference. Only one word, but big difference, right? Deployment is triggered manually and from time to time, and continuous deployment means that something is looking for changes and deploy these changes when they occur. Mm-hmm. So what is nice about those tools is that you can write your own rule set and plug in, let's say, them to the tool. From my experiments, I would say that 80% of efforts from all of them is related to AWS, right? So talking about clouds like Alibaba, Oracle Cloud, IBM Cloud, etc., they even don't think really seriously about Azure and GCP. So even the big three is not fully covered there. Or probably, people who deploy stuff on Azure or GCP are better engineers than those from AWS, right? Or Azure or GCP is so vulnerable that doesn't matter. But yes, the reality is that most effort is going to AWS for everything, every of those tools, even those which I didn't touch. So they are third party, but still. If there is no more question, I would like to stay in touch if you wish. And yeah, thank you very much.
Guys, thank you for joining. It's all for tonight, unless you have more to talk. Nothing else?
No, it's enough. It's enough. Definitely enough.
Thank you, Natalia, for your presentation. It was really good. Also, Pavel. I would like to add something like sometimes people may think, oh, it's Twitter. Everybody wants to hack these big companies. But as Pavel was showing, believe me, all the companies are targets nowadays. It's about data, not about company itself. So it doesn't matter where you work or how you work, you are a target somehow. And as Pawel was mentioning, for this kind of infrastructure as a code, there is always a breach, always another tool, always something. And as an application security engineer, also advise you put at least one tool, start something, do something, because it's about knowing our problems. Usually companies don't know and they are not aware what's happening, and that's most important. Yeah. So again, thank you for joining. We can have some beers. Of course, you pay. I'm not paying, and I have some time. We can chat and meet each others. Thank you, guys. Thank you, people online as well. I know cameras.